Hello, hello, hello. How are we doing? Let's see if we have, I already have one. Oh, it's from Mr. Ryan Lally right across the way. You love to see it. Glad that you're hyped for the stream here. Ryan is in the office next door to me right now. If anyone is joining us, let me get the URL for you all and share that with you. 1 second here. If anyone wants to check in, and we'll put our slides back up. It's been a minute since I've done a Global Hack Week stream. I'm excited for it. I think the last time I streamed for a Global Hack Week has to be more than 6 months ago. If you're interested in joining us today, though, that is going to be the link for the day where you can join in and check in. And I'll actually look at this. I'm even prepared with a short link and a QR code as well. So I'm going to give it a minute or so for folks to roll in. We're going to be doing a Vector Search 101 workshop today. I'll cover some slides, some little background theory so you know what exactly vector search is. And then we'll actually go through a quick start together for vector search and have, using some sample data from MongoDB, actually do some real queries ourselves using Python, which I'm excited about. I think Rosendo normally does this in JavaScript. We're going to switch over and use some Python today because that's my personal favorite. I will give it another couple of minutes here for folks to roll in, but if anyone is got any questions or anything like that, more than happy to answer them. And otherwise, we'll get started in probably another minute or two. I'm glad to hear that I'm doing great already. I feel like I'm going to get trolled this entire stream by Ryan, but we'll see if that's true or not. We shall see. Alrighty, and let me see if I can see who is in our audience here. They made a bunch of updates to StreamYard since the last time I used it as well. It's very fancy now. They were asking me if I wanted to stream vertical video or horizontal. I figured that this might be a better workshop if we did it horizontal, but if anyone in the crowd is really feeling that vertical video moment, we certainly can switch. So I think I can switch my monitor to be a vertical display for the sake of that. And let me check my clock here. We'll go ahead and say we'll start at 03:30, so getting another 45 seconds or so. Anyone feeling brave and want to say what they're hacking on this week, or maybe a favorite stream other than this one, of course? See if I can get any interaction out of my chat. Yes, the TikTok stream, exactly. Alrighty, let me get myself resized here. And I'll say it now, but I'm gonna have to remember again. When we swap over to do our coding later, I need to remember to zoom in quite a bit. I have a gigantic monitor in front of me, and I always forget to zoom in when I'm doing these, but I'll do my best to remind myself. It looks like we just got a bunch of new people who joined us as well, which is great. Perfect timing. Hello. Hello. From Michigan, you'll love to see it. Is Michigan is it pure Michigan? Is that the state slogan? Am I remembering that correctly? You're gonna have to tell me if I've just fabricated that entirely. It's like on the license plates, maybe, is that it? But anyway, that's an aside here, I suppose. All right, friends. Once again, you can join us by just heading to this link here from Winter Wonderland. Oh, is that the slogan? I see. The Winter Wonder Hack was a hackathon in the Upper Peninsula for a long time, and Pure Michigan. Okay, all right, I'll take it. Partial credit for me there. So we are going to go ahead and jump into it here now that we've got a few more folks who've hopped in with us. Again, make sure you check in and register for the workshop. You'll actually get a follow-up email with the slides I'm going to go through, as well as links to all these resources, but we'll kind of go through and do everything together here as well. Once again, this is going to be Vector Search 101. We'll do a little intro to vector search here today. Normally, Mr. Rosendo runs this workshop, but it is his birthday today, so I am filling in for him. Got some big shoes to fill, but hopefully I could live up to the hype there. Before we get going, we'll go over a quick agenda so you know what to expect. We're going to cover over the next 40 minutes or so, we'll go through some slides. I might be a little bit quicker than that. We'll see. We'll actually do a code sample together and we'll come up and do some next steps on slides again. But over the next few minutes or so here, we're going to cover what exactly vector search is, what are embeddings, how vector search works in MongoDB. We'll actually do a quick start. We'll talk a little bit about tuning vector searches as well. And then ultimately we'll do a little Q&A at the end, and I'll do my best to answer questions on the fly if folks have them. If you're following along at home, you can also complete a couple of the MongoDB challenges here for Global Hack Week API Week while we're doing this workshop as well, or at least it'll get you started on a couple of them as well if you're going for those points. So we're going to start off with what exactly is vector search. Anyone in my crowd feeling brave? Anyone know what vector search is? Just because we do have a couple of people participating. I'll see if I can get some answers from the crowd, and if not, I'll jump into it myself here. I've got a delay, so I'll give you a second here. Trying to see if I can get some bonus activation from my chat. I guess what is vector search is maybe a long answer to type out, but we'll figure it out here. All right, Lolly's got a good one here. So search using embeddings. I think this is totally valid. I think a lot of folks might not know what embeddings are, but fear not, we'll cover that in a second here as well. But we will take that as a bonus point for Mr. Ryan there. So for the longest time, search experiences are typically powered by what's called like lexical search. So you're focused on a specific keyword or a couple of keywords and actually searching for matches of that, right? So in this example here in my slides, there's like 3 different books. And if I search for Greek philosophy, each of these books has Greek philosophy in the name, the subtitle, something like that. And it's actually matching against those. So if you were running an online bookstore, like you might implement lexical search and get these as results. But there's going to be lots of edge cases that this doesn't work well for, right? You might be looking for books written by Greek philosophers, and if they don't have the name Greek philosophy in the title or something like that, it's going to be tough to find those results, right? So if you're looking for something that you don't quite have the words for, if you're maybe remembering like a characteristic or like a theme, maybe even some like characters in a book, something like that. And then as we get a little further along here, you can actually search by like images and other things like that with vector search, which is quite cool. But if you can't remember the exact spelling of the author's name, if you can't remember the exact title, maybe you only know like some extra details about it, you don't have those kind of like exact matches that you might need. That is ultimately where something like vector search can come in and help you out here. So we're going to talk all about vector search here today. It's another technique basically that you can use. And particularly right now, there's been a lot of excitement around vector search with all of the AI and large language model stuff that's going on. So this is going to retrieve results based on kind of the intent of the search. We'll get into how that actually happens a little bit further along in their slides here. But now if you updated the same exact search interface and you were using vector search instead, here you're going to get a different set of results when you search for Greek philosophy. Here we're getting a couple of books by Plato. We're getting something by Aristotle, right? And so this is kind of that example I was talking about where maybe we are looking for literature written by Greek philosophers versus books with Greek philosophy in the name. Here, really, again, it's like aligned with the theme as like the way to kind of think about this or the way to parse it. That making sense to my my chat so far? Refill myself on some coffee there. While you all type out your answers, you can take this a step further, right? So if you were maybe searching for Harry Potter, you can type in fantasy novel about a boy in a school of magic. And this is going to get you a couple of different books, right? Harry Potter is not the only book that fits that description. Maybe it's a very popular one, but here you can see a couple of other examples of search results you might expect in this situation, right? So you can kind of like start describing things. You can really focus on the intent of the search versus, again, like the specific exact words or exact match. I think I already previewed this, but you can actually do search by image as well, which is kind of cool. So if you happen to have like a cover of a book or something like that, I think this could be maybe cool if you're like, you had the cover in a different language or something. Although for some international releases, it's a different like artwork. But you can do search by image when you're doing vector search, which is a nice little feature. You can actually do more than that as well. You can do full multimodal search if you're using the right like setup for it. So let's just recap here the differences between lexical and vector search. So in lexical, we're doing keyword search. We're retrieving based on an exact match. You want to use this when your text corpus very closely matches what your users are actually going to search. So you can think of like Control F is like a really good example, or Command F if you're on a Mac as a really good example of this. It's going to be a first pass only based on the text-based relevancy. Your vector search is going to be when you're looking for things that are similar, right? Semantic similarities. You might have a vocabulary gap that you're trying to address. Like people might not know exactly what they're looking for. It's much more kind of flexible in the long run, but it's a little bit more complicated to set up. And I already said this here, but again, you can do text, you can do images, you can do audio, video search, lots of other opportunities here with vector search. I don't think we'll see any of that today, but I do think we have it in some of our next steps if you want to keep working on this after the workshop. So we started talking about what vector search is. We didn't actually cover what vectors are, which might be a good place to go back to here. It's been a minute since I took a math course, but we'll do our best explanation of what vectors are here. I know Rosendo makes a joke at this point about Home Depot. For those of you not in the US, I hope that you know what a Home Depot is. You'll have to tell me in chat if not here. But if you were walking around a think large department store like a Home Depot, you're going to see that all the items are organized into different aisles. And then typically they're going to have a bin or even like a shelf in that aisle. So you can represent the location of any of the items in the store using a couple of numbers in this way, right? So you can say like it's going to be in aisle 10 and bin 40, right? And so you can think about this for any different item in the store, whether that's like a specific screw or a light bulb or a gasket or whatever it is. Each of these items is going to have some combination of numbers that's unique to them and pinpoints their exact location. For most things, a two-dimensional vector like this is not going to be enough detail, but it kind of gives us an introductory understanding of how these work, right? So it's a couple of numbers put together, and we're going to use those to pinpoint an exact location in some sort of space. That check out? So if we want to, we talked about vectors a little bit here. The other thing I was giving Ryan a hard time for was that he was talking about embeddings when he described what exactly vector search is. So that's going to be kind of the next thing we need to discuss here to make sure we have the requisite knowledge to keep going here. So embeddings are going to basically, you're going to take data and embed them to actually make this searchable using those vectors or using a vector search rather. So these are going to be numeric multidimensional representations of a piece of information. So here you can see like an example for dog on screen. It's got a series of numbers in those brackets. And that's going to help us pinpoint it in some sort of space, right? Again, like two-dimensional versus three-dimensional versus however many dimensions gets a little complicated to visualize. But the thing to think about is it's a string of numbers that we've somehow set that pinpoint exactly that item. So here you can see dog and cat. Maybe they're pretty similar, but dog is pretty far away from apple on this example here. They capture some of the semantic qualities of the data. So it's essentially going to be a bunch of different characteristics, right? So cats and dogs might both have 4 legs, or they might both be animals, versus apples and oranges are both fruits. So they're going to be at a different kind of section, different aisle of the space overall. If you're going to plot this over, a bigger space, like you can basically get these little groupings, these pairings of similar things in this, multi-dimensional space. So that's ultimately what vectors and embeddings are in the context of our vector search example here today. So then you have to ask the question like, okay, so there are these strings of numbers. How do we actually get embeddings? How do we actually embed data in this way so that we can go through and search it? You're going to use a very special machine learning model to basically embed that data. And then it's as you're setting up these types of systems, once you pick an embedding model, you actually need to stick with it. You can basically redo your whole database and get a different embedding model. But once you have this embedding model, it has a specific way that it embeds things. And that's basically it's basically going to define the structure of your bins and your aisles, if that makes sense for folks in my crowd here. So they're going to convert any piece of information that you throw at them into one of these numerical encodings. They have different models that do different modalities, right? So you might have one that only does text. You have some that only do audio. You have some that are multimodal and do everything. And I see a question there that I'll get to in a second. I actually have a whole lab on how to pick an embedding model that I'll show on the next screen here. So if you're interested in like diving deep into like which embedding model you select and how that's going to impact your results, MongoDB has a really good guide and kind of like workshop on that. In general, if you're just getting started with this, I actually wouldn't even worry about which embedding model, like just take whatever the recommended one is. It's going to be totally fine as you get started. And then once you're like trying to optimize further down the road, that might be where you look at different models in the future. So I'll pull up this on screen, and then I'll actually answer this question, hopefully. So is it like any type of data into numeral list output? Yeah, basically, yeah. So you're going to take, and hopefully the embedding model piece helps kind of formalize this for you as well. But you have this machine learning model that's going to take a text string, a audio sample, whatever it might be. It's going to do some math on it and basically put it into this space, and then give you back that string of numbers. And that string of numbers is what we're going to be searching for. We're going to look as we get further along in our slides. There's actually a couple of different ways you can search for. You can look for other points that are nearby. You can look for things that are like in a similar direction, if that makes sense. And so there's a couple of different ways that you can actually search in this space. But all that model is doing is we're kind of returning back that string of numbers for you. And let me post this link into chat for everybody as well. But if you're interested in diving a little bit deeper in like how you might pick a embedding model, you can spend some time here. Again, if you're brand new to vector search, I actually just recommend using whatever the recommended model is. And you'll see that when we go through and do a live example here in a little bit as well. All right, so we have some existing database and we want to add embeddings to that existing data. To perform vector search, you need to have embeddings, and so you have to generate these embedding arrays as to actually use this technology. So here on my left-hand side, you can see our original data set, and then on the right-hand side, you can see we added this embedding array, and this one has 513 different numbers that are part of that. Here we're searching for books, and basically what we're doing is our books document look like this, and then we are putting them through this embedding model, and that's going to give us a numerical representation of this. So here you can see it actually is pulling in the cover, it's pulling in the year, it's pulling in the pages. These are all going to get embedded as part of using that model. They each might be different pieces of the puzzle, so to speak, right? So maybe your year is embedded with a couple of specific areas, or the title or the semantic meaning of the title is a different section, right? And so as your user is searching, you're basically going to be looking for things that match patterns. Is like the high level way I might explain it. MongoDB makes this really easy to do. All you need to do is add this additional embeddings field. The example we're going to go through in a second actually already has the embeddings done for us, but this is really, really easy to do. And they've got some great tutorials and workshops on it as well that you'll see kind of hands-on in a little bit here. So that is a lot of our kind of background and theory. I am going to do a quick recap, but if you have any questions on theory stuff, let me know. And then we're actually going to jump into doing the quick start together. We'll go through the quick start and we'll actually see some live examples of this. And hopefully those live examples will further solidify everything for everyone in the crowd here. So embeddings are going to be an array of numbers that capture semantic qualities of data. Again, kind of think of the meaning behind the data, right? Greek philosophy versus Greek philosophers, and how we're actually searching for those. Embeddings are going to be generated by specialized ML models, right? So we're not doing the math to create these embeddings ourselves. There's these really special models that we're going to give them some piece of data, and they're going to return us this string of numbers that is important for what we're trying to accomplish. And then finally, embeddings can be added in place into existing MongoDB documents. If you're using a Mongo database already, you can add your embeddings in place right in line with your documents, which is a really nice structure there. You have a little bit of both worlds. So we're going to get into vector search here before we jump into that actual example. I lied to y'all. That's A-OK. So vector search is the next piece of the puzzle here. So we know what embeddings are. We know how to embed data, at least loosely at this point. And here our goal is okay, how do we actually do this vector search, right? So when somebody sends in a query, we send it to the exact same embedding model that we use to embed our data. And then we're going to try and match that against our data and look for similar results, basically. So we'll take that initial query, we're going to send it into our embedding model, and then we'll ultimately query a bunch of different, we'll kind of match against all those different numbers to try and find something that's in the same space. And we'll talk a little bit more in some of our future slides. There's, again, different ways you can approach this, but that's the very high level of it. So this enables us ultimately to, because this machine learning model is also working on our user's query, it enables us to search based on kind of context and meaning, not just that exact match, right? So we're taking the user's perspective, the user's like intent, and we're enabling our search to kind of use that natural language and other things like images, video, etc., to find the relevant or the most relevant results in our data set. So I think this is maybe my most dense slide in the entire presentation here. We're going to briefly talk about how this works inside of MongoDB. I think if you get a little bit lost in this one, like give me a minute, and particularly when we jump into our examples, I think this stuff makes a lot more sense. But in Mongo, there's this algorithm called hierarchical navigable small worlds, or HNSW. The way this works is it creates layers that are connected to this graph, and embedding vectors are nodes, and each of these nodes is connected to some subset of other nodes nearby, right? It's looking for nearest neighbors or their distance in the vector space overall. So you can visualize this kind of as like layers here, like you can see in our graphic. Each layer is going to have its own entry port, and then inside the layer, you're actually moving from node to node until you can't get any closer to where the query is. You can then move to the next layer and repeat the process, and you basically get closer and closer over time. You can also, like if you're looking at my layers here, you can notice that at the start, they start off sparse, and at higher levels, they become denser. So as you go through these layers, it basically narrows down your results to a general region where the vector query actually lies. And then once you have it at the bottommost layer, it's going to fan out and find those nearest neighbors. If I've lost you on this, fear not. Basically, we're going to look across a bunch of different layers. We're going to look for other nodes that are nearby, and then we're going to use those results to ultimately return something back to our user. That makes sense to everyone? I'll pause for a second on this one since we normally get a question or two here. Oh, and if you're interested, I have a deep dive on this as well on my next slide. So like 30 seconds on this slide is probably not enough time to cover it in the detail that you need. Getting the good so far. You'll love to see it. Shout out to Little Sulfur there. I love the audience interaction. If you're looking for a deeper dive, I think this is a full like hour-long video from one of the MongoDB folks. You can check this out. I'll post this in chat as well for folks. But this is a good deep dive into that whole topic that we just briefly covered there. So now we're going to get into a couple of our search approaches here. So calculating distance in vector space. So the goal of a vector search is going to be to retrieve documents based on their proximity to the query vector in vector space. So like in that one of our examples, we had like 513 different numbers as part of the array, right? And so, this is a however many dimensional space. And what does proximity even really mean? So there's some complicated math that we can do to actually figure this out. But we'll break it down here. We'll look at just a simple like XY graph here. We're basically looking for the closest vector in the same space, right? Again, this is oversimplified. You're going to have hundreds, if not thousands, of different dimensions. But in our case, it's pretty simple here for dog and cat. There's a couple of different options inside of MongoDB. The first one is Euclidean distance, which is just like the straight line distance between two vectors. This can be good. You'll see here, like as we go through, like there's other ways to optimize your search results beyond just this though. So to actually calculate that distance, you're basically doing a dot product multiplication. If you're maybe you slept through math class like Ryan did, fear not here, like most of this stuff is going to be handled for you. But if you do care deep, about the theory, we're basically just doing some dot products in the background to figure out the closest. I did sleep through classes. I know it's shocking. I was a bad student in college. I think good student in high school, and then I loved going to hackathons. I loved the practical application of building something versus theory in class. I know it's shocking. But again, here the goal is we're basically just finding the closest example we have in our data set. Another way that you can do this is by actually calculating the cosine similarity, right? And so this is like that direction that is the way I think about this. Basically, before we looked at the actual distance between the two endpoints, here we're looking for things that are like loosely pointed in the same direction. And again, I'm rounding some corners here over our theory, but the way to think about this is directionally the same. That's kind of how I grapple with this one. So if we use either of these distance metrics for our vector search, you might not retrieve cat when searching for dog. You might not receive dog when searching for cat, but it depends a little bit on your data set and what else you have in there, right? Again, if you're using an embeddings model, it's going to help you find similar results if you have a really, really large data set, or if you have lots of different things in there. This can get complicated. Oh, okay. I was like, I thought I had messed something up there. Get distracted by a chat. But basically here, there's a couple of different search methods you can use. And in practice, you're going to want to play around with and experiment with multiple to see which one's going to work best for you in your given situation. We can talk more about that as we go through here. So we'll recap here again. And then I think for real this time, we're going to get into our example. Vector search is going to retrieve documents closest to the query in a vector space for us. We're going to use the same embedding model to embed the data you want to search on, the user's queries, right? So we put all of our data through this machine, right, that outputs these vector strings, or these, vector strings is fine here. When our user actually queries, so they might type in like Ryan Swift or whatever search term they want, we want to put it through the exact same machine so we can compare it. There's a couple of different ways that we compare it. We can do distance in vector space using a few different mathematical functions. Cosine similarity tends to work well with most embedding models, but you can also do that raw distance, Euclidean distance as well. So we will wrap up here with some vector search and MongoDB stuff, and then I think for real this time, we will jump into VS Code. So we're going to generate embeddings. For our example data set that's actually already done for us, we'll create a vector search index. And then finally, we're actually going to send a vector search query into Mongo using whatever connector we're using for it. So here is a vector search index that we're going to use to query our data. This has a number of dimensions. It has the method that we're using. In this case, its similarity is cosine, the path, and all of the other information you need. And then we're going to send in a query, and here you can see that actual query. So it does have the query as a vector already. It has some additional details here, like the number of candidates and the limit. If you are interested in going more in depth in any of this, MongoDB has some great documentation that covers it. For the sake of our example here today, I think the best thing for us is going to be to get right into that quick start so we can kind of see it ourselves. Basically, the number of candidates is going to be a parameter that specifies the number of similar documents that actually returns for us. And then the project stage is going to return documents along with a similarity score. So it's going to give us some like metadata that we can use to continue to evaluate this in the future. Great. Here is all this stuff again. So you saw how easy it is for vectors to coexist with the rest of your MongoDB data. Remember, it's the exact same document, but it just has that little embeddings piece down beneath it. Since you have your operational and vector data in the same space, it's automatically synchronized. It's really easy to work with. And this is also a fully managed service, right? So MongoDB Atlas is going to help you do all this stuff. You don't need to be worried about maintaining infrastructure or like additional components like that for your project. You get to focus on building cool things, which is why I'm so hungry to get into VS Code here. And then finally, if you are interested, there's lots of different things you can do to like scale this and fine tune it further. So it's a nice little ecosystem where it like lets you get going quickly, but there's a lot of depth that you can get into as well once you get further along. So finally here, we're going to jump into our vector search enabled database here. If you want to follow along with me, I'm going to go through the entire process, including getting a MongoDB account and all of that. So you're more than welcome to follow along with me here. I am going to switch my slides real quick though. We'll do our entire screen here in 1 second. Minimize that. Alrighty. So we're going to go ahead and share our entire screen. We'll do our main monitor. Perfect. And let me put that up on StreamYard for y'all. And I'm going to make this bigger for you as promised. And you're going to have to remind me on a few of our pages, I suspect. That looks about right to me. Can I get some feedback from my crowd though? Is this text readable for y'all? I think that's probably good. My system is going to be quite small by comparison, but I'll do my best to zoom in on everything. So this is the quick start that I'm actually going to be using. I will paste this into chat for y'all. And then in my case, one of my favorite features on MongoDB's documentation, they have these nice little like drop downs that you can use to actually specify things that are going to change the documentation. So in my case, I'm using Python. You can select anything you like. Like I think Rosendo uses Node.js when he does this. You can specify different interfaces that you're using, your deployment type. Really, really nice feature, and lets you kind of customize this documentation to your exact, your exact setup. I also talked about Global Hack Week challenges really briefly. If you're interested, you can actually earn a skills badge from MongoDB here as well, if you'd like to follow along and do this as well. So in our case here, if you are following along directly with me, I'm going to be doing this with Atlas Cloud. I'm going to be using a driver, and I'm going to be using Python. So if you want to select the exact same settings, that's what I'm going with here. Let me do one more click on this. So our objective here, and this shouldn't take us more than 15 minutes. We actually might be faster than that because I've got some of the setup here already, but we are basically going to create we're going to use an example data set, this embedded movies data set that MongoDB provides. We're going to have a embedding here that we're going to use, and then we are actually going to use dot product, which I think is Euclidean distance, to actually determine our query results here. We're going to run search queries against this and actually get some results back as well. So you'll see those in, like, we'll do a little command line interface to actually make this happen here. But we're going to fully set up a database. We'll use a couple of sample Python scripts that they have for us here, and we'll embed our own search query and send that up to MongoDB and get some results back as well. So our first step here is going to be actually setting up our MongoDB cluster. So you can just click in on these links here to do this. I'm actually going to hop into MongoDB myself, and I'm going to make a new project. Let me do one more click. 2 more clicks. We'll get 200% is our objective there. So I'm going to name this Global Hack Week API Live or something like that. I don't need to add any tags here for this project, and you don't need to either. If you want to, you certainly can, though. I'm going to go ahead and hit next. I am the member here, the project owner. I'm just going to go ahead and hit create project. Great. And then our next step is going to be to create a cluster. And we can actually tab back over to our documentation to see that as well. So we're going to create an account. If you don't have an Atlas cluster yet, you can create a free M0 cluster. These are free forever, as far as I remember. And we'll actually be able to add in our data really easily just using the graphic interface in this as well. You can only create one free cluster per project. So if you have an existing project, you might still need to create a new one for this. So let's actually go through and do that here. Bunch of different settings you can pick from here. These are some of the paid options. I'm going to make sure I select this free one. I'm just going to name this the exact same thing, Global Hack Week API Live. I'm going to select, so we'll use Google Cloud for this, and your region and this stuff shouldn't really matter. This is not a production DB or anything like that, but I'll pick Iowa and Google Cloud here, and I'm going to actually go ahead and hit create deployment. Oh, and I should have clicked on preload sample data, but we can do that on our next page as well. So typically you wouldn't want to reveal your username and password. In this case, I'm going to wipe this database right after our workshop is over, so I'm not going to worry about it too much here. I'm going to go ahead and hit create database user, and then choose a connection method on my next page. I'm going to select drivers in my case, and that is going to match what I did in my interface up here on my documentation. So I'm going to click on drivers. In my case, I'm going to use Python, and this is going to give me installation instructions for PyMongo here. And this little snippet here, I'm actually going to copy. I'm going to open up VS Code, and I will actually do a new folder here real quick. We'll do a new folder in this. We're going to call this Global Hack Week API Live. I apologize. I'm sure that's very tiny for you all at home. But I'll zoom in VS Code here in 1 second. Great. So we're in a brand new project here. I'm going to do a new file. I'm just going to call this like temp.txt, something like that. And I'm going to stash this here for 1 second. Then get rid of this welcome, and I'll open up a terminal as well. Gotta get our system ready to rock here. Anyone following along with me at home? Or are you all just watching me do this? Cool, so I'm gonna go ahead and hit done here on this. I've got what I need. Next up, I'm gonna load in my sample data. I could have done this ahead of time, but okay, I'll just click the button to do it here. And it actually pre-fills the sample data set that I'm looking for, which is great. So I'm just gonna hit load sample data. This is gonna take a minute to actually load in that data for me. But if I refresh this page, we should start to see it here, if I remember correctly. I need to click into clusters. Yeah, it's still loading our sample data set here. Cool. So let's take a look at our docs while we wait. So this is that sample database that was already pre-recommended for us, which is great to see. We want to check that the database actually contains embedded movies collection. We hopefully will see this in practice in case any of you are doing this at home. But if I think we have to browse collections here. Let's see if we can find this. So here you can see that we already have comments in theaters loaded in, but we actually don't have this embedded movies collection just yet. We'll give it a second, like it's still loading in all that data, but the scripts further down below are actually not going to work unless we have that data loaded in, and it's going to take a second to actually get all this stuff loaded into our DB for us. This gives you a whole way to go in and check using Atlas Search and all that. So in the meantime, we can go and do some of our setup. We can actually make our little vector index Python file here as well. I am going to go ahead and do this though. So I'm going to use PyMongo here. And you might want to do a virtual environment for this. If you're not sure how virtual environments work, there's plenty of great resources online. You can also use something like UV is really popular these days. I'm just going to use this right here and then uninstall in a second. I'm not going to worry about it too much. But I did a simple pip install for PyMongo, and then I'm going to grab our vector index as well, and I'm going to save this as a new file. So it's going to be vector-index.py. I'll go ahead and save this as well, and we'll get rid of that recommendation. So we do have to update some things here, like our connection string, but let's go follow our documentation specifically. So we just defined our index, great. So there's the definitions in here. So it's 2048 vector dimensions. It's going to use dot product for similarity. It's going to do automatic quantization of our vectors. And then finally here, C is going to be our specifying our connection string. So if you remember, I stashed that in temp. Again, in real life, you probably don't want to expose this password to folks, but for the sake of a little workshop here, I'm not too worried about it. So I'll go ahead and save that there. Great. And then we should be good to go. Next is going to be actually creating an index. So we'll just run our file. So we'll run python vector-index.py, and we should get some output like this. Before we do this, though, I do want to make sure our data is fully loaded in. So I'll go ahead and refresh. Yeah, .env, you can do it in a couple of different ways. So here I see embedded movies is in here. Let's take a look at an actual example before we get too far. So here we have Scarface, a classic. We have a little plot. We've got we have multiple plots, in fact. We have a poster for this. And let's see if we can actually see our embedding stuff is down here as well. So we're good to go on that. Great. We have a type for this. We have the year. Awesome. Let's take a look at awards just because I'm curious. So 2 wins. It's interesting how they have that structured. I would have assumed that you needed to be nominated to have a win, and we can even click in and see some of our writers, some of our directors, so a bunch of cool stuff in here. Cool. Great, so let's pop back in here. So we do have the data that we're expecting. So we can just run Python and vector-index.py. If you're new to command line, I just use tab to auto-complete that there. And hopefully here, there we go. So new search index named vector index is building. We're gonna basically poll to see if this is ready. This can take a couple of minutes. So this is kind of like a one-time setup step, in our case at least, because we're not going to be adding additional records to our DB here. Or documents, I really should say. The next step here is going to be actually running a vector search query, and we can kind of get started on this while we wait for that index to occur. So this query is going to search documents that include text in the plot field that is going to be semantically related to time travel. And we can actually try and tweak this ourselves if we want to. But we're going to grab this name here. The name doesn't really matter, but just so we're following along, we'll do that. Do a new file. Great. And you can actually see that our vector index is ready for querying, which is great. Here, we're going to grab our code again. We'll paste this in. And just like last time, we do need to update our connection string. And we'll save that. And so here it has a bunch of our stuff predefined for us as well, which is great. And let's see if we can't find. So this actually has a query predefined for us as well. So in reality, you would need to, like if you were doing this in practice, you would actually want to vectorize your search query yourself. In this case, it's actually going to be pre-configured for us. So let's give this a shot and see if this works. So I'm just going to do Python and then Atlas vector search. Great. And so again, this is related to time travel, right? So let's see what we got here for some of our results. Let's see if it matches what we expect. So, it's going to consider the 150 most similar movie plots and return the top 10 results. It uses the project stage to only include the movie plot and title fields, add a score. Okay. Run your query. Cool. And so here, I'm expecting similar results to this. They might even be identical. So yep, looks like they are. So plot at the age of 21, Tim discovers he can travel in time and change what happens and has happened in his own life. His decision to make his world a better place by getting a girlfriend turns out to not be as easy as you might think. Title is about time, and then it even gives us a score value as well. So let's look at the difference out of curiosity. So our lowest ranked in the top 10 is a 0.74, and our highest rank is a 0.77. Pretty cool. So learning summary here. So the thing I'm actually curious about, and I apologize because I should have come in ahead of time. I'm sure it's in one of these next steps here. So a good next step for anybody at home is actually figuring out how to do this query vector yourself. In this case, like I said, they kind of pre-configured this for us, but I'd actually be curious to edit this so that you can come in and come in here and like submit your own queries basically as part of this little practice. If you're interested in RAG as well, this is probably a really good resource. I know that's been like something I won't say every hacker has asked me about recently, but lots of the folks I've seen at events have been curious about retrieval augmented generation. So they have a good resource for that in here as well. So let me pop back over to our slides. We have a little bit of kind of wrap up and recap. And then if anyone does have questions as well, more than happy to answer those. Hide that real quick. Stop screen. Alrighty. And we'll share our laptop screen. Great. And let me see if I can't find my slides again. How's that working? You'll love to see it. All right. So we'll do a quick recap here of what we learned so far. So to perform vector search in MongoDB, we need to actually generate embeddings. We did that with that first script, and create a vector search index and ultimately send a query, which is what we did with that second script. The number of dimensions in the vector search index is going to depend on the embedding model that we use. And it's important to stick with the same embedding model, and you're actually going to use that embedding model for your end users' queries as well. And then vector search is always going to be the first stage in a vector search aggregation pipeline. You want to do a little bit more to actually optimize in the long run, right? Here we saw we got like 10 different results. There's probably more that you can do to make those results even better for folks. And we'll jump into a couple of things you can optimize for as we move towards our Q&A here. When you're working with really large data sets, or you have business constraints like cost or latency, things like that to worry about, there are some techniques that you want to apply to actually optimize things here. Pre-filtering is a big one. So in many cases here, we will see that folks actually want to filter the vector search results based on a business logic, right? So in Mongo, you can actually do this as a pre-filter for vector search. Essentially, you're going to apply the filters to your collection to produce a filtered set of documents, right? So we have that giant database of all these different movies, and we can actually pull it back up. But maybe we only wanted to look at movies that were, pre-1950, or we wanted to look at only horror films or some other tag that we had there. Actually, a really good example might be we only want to search for movies that won a nomination for an award category, right? We looked at that in our data set. Essentially, you're just going to apply those filters first, and then you're going to do your vector search after. And so it's going to be an even tighter kind of search result in the end. If the number of filtered documents is more than the number of documents returned, you're going to get that kind of like nearest neighbor. And again, remember all of those like traversal methods where you're going through those flares and looking for those nearest neighbors. Oh, I should have been clicking through as I went. My apologies, gang. So in most cases, as long as your filters are not too restrictive, you're going to find that nearest neighbor. And again, the pre-filtering is going to help you reduce some of those costs. It's going to reduce latency. It's going to make your search a little bit tighter overall and make it a better experience for your end users is your goal there. You might also be asking why you would do pre-filtering instead of post-filtering, right? You could do the exact same. We don't have, I apologize for getting distracted here, but no hackathon this Global Hack Week. The entire week is a hacker festival. So it's kind of like a pick your own adventure over the course of the week here. Lots of different challenges that you can do, all sorts of cool things over the course of the week. You're welcome to jump in and out of any challenges you like, but there's no specific hackathon. If you head to, I'll put it in chat for you as well, MLH.io/events, that's going to have all of MLH's upcoming events, including Global Hack Week on. So you might be asking, like, why not post-filter instead of pre-filter? In theory, they should have a similar result, right? To examine that or to answer that, we should look at an example here. So in this case, we have a query vector, and it's a vector similarity to documents in the books database that we've been referencing. And we're going to say that someone has indicated they only want books to have less than 100 pages, right? If we apply this as a pre-filter and the K is set to only retrieve the top 2 candidates from the vector search, then the vector search is going to exit as soon as it finds those 2 candidates. But if we apply it as a post filter, we still end up doing the full search and then grab these 2 documents with the similarity score. So with post filtering, we really don't get any performance gains while also running the risk of no results being returned. So here, if we pre-filter, like these are the 2 that we're looking at specifically. And if we do post filtering, there's not actually going to be any sort of impact. We're going to get the same results, but we've actually run our search against a bigger data set and kind of like wasted resources, wasted usage. Adding pre-filters to vector search is going to involve 2 different things. So first, updating the vector search index definition to include the filter fields. So this is actually defined in that kind of first script that we did. In this example here, we have a type and a path, so it's a filter pages, set to filter pages respectively. And then the other changes in our vector search stage of the aggregation pipe. Apologies, friends. In our aggregation step of the pipeline, you'd include a filter field containing a pre-filter expression. So in this example, we have the filter set to pages of 200 or less, right? You could do this for any value you wanted, though. So again, we're going to do another recap here. You should use pre-filters to filter your vector search results based on certain criteria. Pre-filtering can slow down the vector search if the filters are too restrictive, though. And post-filtering is not recommended because it can be wasteful or not effective, basically. Mongo has a really great AI learning hub, which is kind of going to be our last kind of recommendation for you here today before I jump into some Q&A. But I'll get this link into chat for y'all. /AI-learning-hub. There you go. And with that, we'll jump into a little Q&A here. If you are with me at the end here, make sure that you've checked into the event as well. While I wait for some questions to come in, I'm actually going to log into Organizer HQ and see who has joined me here today. I might do a little raffle with folks who have checked into the workshop. So I'll hang out for a second here and answer any questions. I'll get my phone because I need a 2-factor authentication code as well. Alrighty, so let's log in here. Any questions at all from my crowd here? I guess I just explained everything so perfectly, you know. That's what I'm hearing here. All right, so I'll jump in here and manage this event and jump into our registrations. And can I filter this just for check-ins? I might have to download it to do that. Great session, you learned a lot. You'll love to see it, that's excellent. So let me see here. Well, I feel like Little Sulfur has been active in chat more so than anyone else. I'm not going to count Ryan Lalu because he's a MLH coach. Anyone else who wants to Nazareth Trains, I'm going to do a raffle. I'm going to give out a swag drop or a surprise prize, whatever we're calling them these days. But if anyone would like to enter into my raffle here, so far, I think I just have 2 folks who've asked questions. So it's going to be a tight crowd. Potentially a good chance to win some swag from MLH. But anything you like in chat, and I'll roll that swag drop in a few seconds here. Cool. All right. So there's a 50-50 shot here. Is it going to be Little Sulfur or is it going to be, who is our other person? The person who asked about hackathons. Oh, we got one late entry here. I'll take it. I'll take it. So it's going to be Little Sulfur is going to be 1. Our hackathon question asker is going to be 2. And Uba, or whatever, however I pronounce this name, you are going to be our number 3 on our raffle roll here. Number 3. All right, this is not our official results. I'm just bringing it on the screen for you all here. I gotta exit out of my slides though. We'll re-roll live here in a second. All right, so we're rolling between 1 and 3. Hope y'all are excited here. Let's see what we get. Number 2 is our friend who asked about hackathons. So if you open up a ticket in Discord, we'll get you a surprise prize if you're interested in some swag from MLH. And then because they were particularly active, I'll give out 2 surprise prizes. I'm feeling generous here. The Global Hack Week team might not be happy with me, but Little Sulfur as well. If you open up a ticket, we'll get you a surprise prize as well for all your questions and interaction. So just go ahead and take a screenshot if you need it. And with that, that is going to be all of our content here today. I'll do one last ask if anyone has any questions, and then otherwise I will see you all later on. Loved the session. Thank you. I'm glad to hear it. I fear that I'm not as strong as Rosendo is. You know, I don't know if you all have been to Rosendo's other sessions. I feel like he's got the better stream personality. Well, I appreciate you saying so. Thank you. Great. Well, I appreciate you all coming out of the woodwork to say so at the end here. It was fun doing this with y'all. If you are interested in doing any of this yourself, Mongo's got great documentation, like you saw me follow it basically verbatim here. They've got some really good next steps in there as well. So I definitely would recommend that. And with that, how to redeem your swag drop. Just take a screenshot of this and then you'll hop into the Discord and just open up a ticket and say that you want a swag drop on screen, or on stage rather, and Siddharth or Mary will help you out with it. So open up a ticket on the MLH Discord though. Alrighty, friends, it's been a pleasure. Make sure you check out the schedule. I think in just a few minutes here, we actually have a Today in Global Hack Week coming up. So make sure you join in for that. Let's double check that actually, now that I'm saying it. Hold please. I think it's at noon every day, so I'm almost positive, yes. In 5 minutes time here, you have a Today in Global Hack Week. So hang tight and enjoy that. And then otherwise, we will see you all at another event sometime soon. Thanks everyone, happy hacking.